is stop my share and let Ernest take over. Ernest, it's all yours.
Thank you very much, Mr. Berry. Can everyone see my screen?
Yes.
Thank you, Mr. Berry. Thanks for allowing me to present today on the future of drones in North Texas. I'm Ernest Huffman. I'm the Aviation Planning and Education Program Manager for North Central Texas Council of Governments. I also manage our Air Transportation Advisory Committee and the North Texas UAS Safety and Integration Task Force. Just a bit of information on for you guys. What's drone technology? Drone technology is professionally called unmanned aircraft systems. Unmanned aircraft systems are an unmanned aircraft and associate elements, which include communication links and the components that control the unmanned aircraft that are required for the pilot and command to operate safely and efficiently in the national airspace system. Currently, drones and other aircraft, these are they operating in and outside of a metropolitan area. As you can see, in an urban environment, there aren't many drone applications being used outside of certain special conditions. But outside of the urban environment, you can see drones being flown recreationally, aerial videography, agricultural applications, rail inspection, search and rescue, package delivery, etc. Now, the overall goal is to get all of those applications efficiently and effectively operating in the metropolitan area, including urban environments, and that's where we're headed. Just some numbers, current numbers from 2019. The drone industry has a potential to create a $5 billion market in the US, and that's an unconstrained estimate. Under 180,000 Part 107 pilots are currently certified. We had 87.8 million flights conducted in 2019, with 470 million people rescued around the world from drones. Insurance companies were able to save 5.5 hours of time and over $300 per inspection. And cell tower inspections costs were reduced by as much as 50% overall. And those stats come from DJI. Some other numbers, and this is a 5-year estimate. And the source for this information is Airspace Link. Drones are expected in 5 years to be able to be serving 53.9% of the population. It will allow recovery of up to $582.5 million per year in total savings for customers. It will support 3.6 to 6.6% of the metropolitan residents who lack access to a vehicle, help 22,000 people with mobility challenges to obtain their prescription medication, generate up to $284,000 per year in new annual sales for a participating local business. It will avoid up to 290 million miles per year in road use and reduce up to 580 car crashes per year, and also reduce up to 113,900 tons per year of CO2 emissions in our airspace. Now I want to get to autonomous drones, because autonomous drone use in a metropolitan area and in a rural area that's the best business case for most operators, okay? Level 0 is no automation at all. That's where the drone control is 100% manual. Then we get into low automation, where the pilot remains in control, but the drone has control of at least one vital function. Level 2 is partial automation, where the pilot remains responsible for safe operation, but the drone can take over heading, altitude under certain conditions. Level 3 is conditional automation, and that's where the pilot acts as a failback or fallback system for redundancy, and the drone can perform all functions given certain conditions. Now, currently there are operators, in particular military and others, who are operating at this level of autonomy with drones. 4 is high automation. That's where the pilot is out of the loop and the drone has backup or redundant systems so that if one fails, the platform will still be operational. And then this is where we want to go, is full automation, where drones will be able to use AI tools to plan their flights as autonomous learning systems. Now, the two main differences between level 4 and 5 is 4, the behavior of the drone is still programmed by an individual, where 5, the drone, through learning from AI tools, will be able to determine its own course of action based on the job it's given. And that's where we're headed. But why are all our autonomous drone operations important to you, important to industry and others? And folks, is money. The main cost benefit for drone use and the way and the means that you're going to be hearing about today in commercially is autonomous, is to get the pilot out of the equation. 9 times out of 10, the highest cost center will be the pilot. To eliminate that from the cost structure will allow these drones to operate at a significantly lower cost, save businesses a lot more, and all those benefits we anticipate from getting drones will be realized in this condition. What are some future uses for autonomous drone technology? We'll get automated food and package delivery, accident and emergency response, search and rescue, surveillance, security surveillance, crop dusting, mapping and surveying, air taxi. Think of the Jetsons with that, and you hear more about that from Mr. Holvey. And there will be numerous, plethora of applications that haven't even been discovered yet that will be opened up from autonomous drone use. So here's a future look on what that drone operations will look like in the metropolitan or overall in the metropolitan area. We're looking to have air taxis operating in and around an airport environment where you see vertiports scattered throughout the region. You'll see helicopters operating in the same airspace, small GA aircraft, small UAS aircraft, commercial jets, all operating in the same environment. And that's what we're looking for a future operating case. But there are some key barriers to integrating this technology into the metropolitan area. And that's the work that we're doing here at the COG and with the task force. And I'll get into what those are. From a safety perspective, we need to understand and we need to make sure that these aircraft operating in our urban areas are safe. Aviation is currently probably the #1 the safest transportation method in the country, and we want to keep it that way. We need industry collaboration. Now we're seeing a lot of collaboration with industry, but 2 years ago, this wasn't happening. And without that collaboration, we won't have the brain power to solve these integration issues. Public engagement and perception. So we want to make sure that we engage the public, educate them on the uses of drones, how they're going to benefit you, how you can get involved, but also we want to improve upon the perception. Before I got involved with this industry 2 years ago, my perception from drone technology all came from movies and things like that. For example, like the last Spider-Man movie came out, the drones were all used to kill people, and that's how I was. That's how I thought of drones. And I know if me, an aviator, thinks of drones in that manner, we see the military using drones for warfare and things of that nature, we need to improve that public perception so that when you folks see drones engaging in their business above your heads, you know what they're there for. We also need to educate the public on what drones won't be used for so that we understand that it's a safe, effective, and that they're being used civilly in our airspace. Education and training. There's a huge issue with standardized education and training worldwide. From a regional perspective, we want to look at education and training and make sure it's standardized and make sure everybody's getting the most proper and most updated training available. Workforce development. When I say the industry has the potential to be a $500 billion industry, that's not a lie, and it may be even more. North Texas currently is #2 in aerospace and air transportation. In order to stay that way, we need to make sure we develop the workforce to matriculate into this UAS industry, and we're working on that. Regulations. We need to make sure that the cities, the state, and federal regulations effectively and efficiently integrate technology in the most cost-effective way. We need to make sure that the technology is where it needs to be. And last but not least, that we have the ground infrastructure and airspace infrastructure in place to ensure that these aircraft operate safely. So what are we doing as a region to prepare? There's numerous university research projects going on. Every major university in our metropolitan area is undergoing research: UTA, UNT, UTD, SMU, almost everyone. And that's important. We're currently leading the nation as a region in public safety adoption of the technology. And you hear more about our PCERT team later. We've been leading the nation in adopting UAS curriculum at all school levels. Drone manufacturing is done heavily in our region. You'll hear from Bell later, but we also have numerous small UAS manufacturers located in our region, and we're looking to attract more of both air taxi and small UAS manufacturing. The North Texas UAS Safety and Integration Task Force is put in place, and you'll hear more about that in a second. We've also been doing a great job now of collaborating with other entities around the country, including the Urban Air Mobility Policy Collaborative, which is comprised of other regions integrating the tech platform around the country. And we're working on standardized policy, and the NASA Advanced Air Mobility Working Groups, where we're working on all the technical issues of integrating the tech platform into a metropolitan area. So let me get to the task force really quick. The objectives with our task force is to promote UAS safety and standardization, mitigate reckless UAS operations, promote the integration of UAS or drones into the DFW region's airspace and metroplex, and to collaborate with regional partners for a coordinated, comprehensive approach to do so. So here's a quick demonstration of how that is broken out. You can go ahead and screenshot that, and hopefully at the end of this, you'll get these slides so you can take a look at this later. But I want to point out a few groups. So our PCERT committee and team, that's our public safety unmanned response team and committee. That is comprised of maybe 50 plus law enforcement officials, public safety officials who are looking to get standardized training for those folks, coordinating to get funding, and also training together to create a team that responds to regional high incident events, like tornadoes, anything that will require a coordinated response. Those guys and gals are leading the nation in that training, and I wanted to highlight them. Also, not listed here is our 911 team is working with schools now to develop a program where they're 3D mapping the insides of schools for their 911 dispatch. You can get more information on that if you contact me. I think that's very important for educators to know about.
Ernest, just to drop in on that,
Yep.
Bill Swope is going to be here, and he's going to be part of the programming workshop. So
Good.
if you want to learn more about that, go to the programming workshop.
Yeah, and I seen David Dean, who runs that program, is also on the call. Thank you for David for putting that together. So the task force, we started in 2018 with maybe 20 members. Now we're up to 280, 140 plus organizations. And you can see how that's broken out here, the market share of the different types of groups. But everybody who's invested, anybody's invested in integrating the technology safely in your region, and you guys need to know it's going to be done correctly. When you see air taxis flying in your sky, know we're doing the work to make sure that was safe. Notable accomplishments to date. Getting that 140 plus organizations collaborating. I don't think that's being done anywhere else in the country. So I'm glad that we were able to get that up and running. We've created our first public education workshop called Know Before You Fly Your Drone workshops, where we're educating the general public on drone safety, where to fly safely within the region, where to get training, where to go to school, how to get your Part 107 license, etc. That's a free workshop we're now doing virtually that you all are invited to, including your students. Public safety UAS response team, what I just mentioned. We've helped Mineral Wells, Texas, in its establishment of an 8th UAS-related testing site. We helped with DCCCD's first registered Department of Labor UAS apprenticeship program, and we've also helped with dozens of school districts getting drone-related curriculum and support. So just to wrap it up so we can get to Mr. Hovey's presentation is, folks, I just want you to know that drones are here to stay. We think, and me as an aviator, I think of drones as the newest and greatest next best thing in aviation, where anything within STEM that the kids are learning, they can matriculate right into the drone industry. There are going to be tons of jobs, I think, available for folks in the upcoming future. So educators, we need your help. Continue to get drones incorporated into your curriculum, into your STEM classes. Keep educating students on drones because it's going to benefit them, in particular in our region. They're in the best place probably on the planet for that. Well, thank you. And I'd like to get on Mr. Hovey's presentation. Thank you, guys.
All right. I'll
So
go ahead and
Dennis, you've got to let go. Oh, there we go.
all right. And so I will take over, start screen sharing on my end. Should be able to see my presentation. I'm going to go into presentation mode. Slideshow. All right. Let me know if y'all could see that okay.
Yes, I can see it.
Excellent. Excellent. All right. So my name is Matt Holvey. I am a senior manager of intelligent systems at Bell, formerly Bell Helicopter, and I'll talk a little bit about the
Okay, Matt,
transition.
I'm sorry to interrupt. I
Yeah.
just have your your PowerPoint before it went to a slideshow.
Oh,
So if you go to slideshow and make sure that it is set up for on the second selection, it will work better.
let us give that a shot. Thank you for
Sorry about
letting me
that.
know. No, better than me talking for 15 minutes and finding out wasn't doing what I was trying to do. All right, let's see. So it should be,
So if you click on slideshow at the top as one of your choices and then choose the second one, which is a window, then it'll present within a window. There we go.
all right. So, and then let's, is that doing it? Is that switching?
Yes, perfect.
Fantastic. All right. Okay. Back in business. I should be better with technology given my job. Okay. So I am the senior manager of intelligent systems at Bell, formerly Bell Helicopter. And I'm going to talk a little bit about why we dropped the helicopter from our name. And then we added flight at the end, Bell Flight, for our websites and other media, because there are a lot of bells out there, admittedly. Again, I'm the senior manager of intelligent systems, and what that means is I own digital transformation, digital innovation within Bell, and that involves engineering tools internal to the company, as well as external products and services that Bell might offer in the future. That completely encompasses also infrastructure related to advanced air mobility. So that includes planning vertiports and the software needed to help vertiports run, as well as the ground to air infrastructure necessary to keep drones flying securely, and future air taxis, which really are just very, very large drones that carry people. So moving into Bell's legacy, our existing product line spans commercial and military aircraft, helicopters predominantly, but we do have the V-22 tilt rotor. For those who are unfamiliar with it, the V-22 Osprey is used by the Marines and the Air Force as a vehicle that can take off vertically, and then those large rotor systems rotate forward and it flies like an airplane. That makes it uniquely qualified to do forward deployed remote operations and then fly quickly to contested areas and do a wide variety of utility missions, everything from cargo hauling to emergency evacuation and rescue operations. We also have the Fire Scout, MQ-8C Fire Scout, which we build in collaboration with other partners, and that is an unmanned vehicle being used by the Coast Guard and others as an autonomous unmanned helicopter. The reason I put this up here, not to spend a lot of time talking about what Bell does, but really to talk about Bell's legacy. This is 40 plus years of industry on this slide. And historically, the aerospace industry is slow to evolve, slow to innovate. It's highly regulation intensive. It's a low volume, high mix industry, which means that we don't sell a lot of aircraft compared to automotive. And it's high mix, meaning each aircraft is frequently customized in very specific ways for a use case. So where you might see a 429 helicopter or a 505 helicopter, someone might buy it for utility use and strip it down to bare bones to carry the most cargo it can. Others might buy it for a VIP experience and stuff it with comfort luxuries, and still others might buy it for survey and rescue or parapublic operations, and so they might want cameras mounted on board and other sensing and lights for night flying, spotlights. So it's a low volume, high mix industry with low automation, that we don't make enough aircraft to justify building autonomous lines that can spit out 3,000 of these a year. It's highly regulated. Innovation is slow. And so we've kind of run into a plateau over the last 20 years of incremental improvement in vertical lift aircraft, but nothing truly innovative since we produced the V-22. However, Bell has 80 years of innovation, and we've done some very radical things. You'll see on this page, most of the pictures are black and white in what we would call the golden age of aviation. And we're in the far upper left-hand corner, we literally have a guy flying a drone. Battery technology wasn't exactly as it is today, so that's clearly a tethered aircraft. But they're flying a drone manually. I don't even know what year that was. And then we broke the sound barrier with Chuck Yeager on that slide. We were the first to break the sound barrier, and we were the first in the United States to fly a true jet engine. And in the very center there, we've got this large multi-rotor, ducted rotor vehicle doing air taxi type vehicles before it was even cool to do so. And obviously there's jetpacks, and we've done lunar landing stuff. So there was a time where we were not plateauing with incremental gains. We were radically innovating in a golden age. But then as kind of like the formation of a planet, there's a lot of heat and energy and inefficiency. But then as that cools and as we solidify and grow roots and we start optimizing these designs and truly start generating revenue, that's the opposite of innovation. It's sustained, getting return on investment. But as technologies have radically transformed in the last decade, we're seeing a new golden age infused with new energy. And so we have to shake out of our legacy heritage that we've been building to for the last 40 years and recreate the slide with modern technologies. And that's exactly what we've done. Switching between this and my notes, so sometimes I lose my mouse. All right, so air taxi. So we're working on the Bell Nexus air taxi, and it's a multi-rotor vehicle powered by electric propulsion. It's the plan is for it to be fully autonomous, but regulation will likely delay full autonomy of vehicles carrying passengers. And so it's going to start with a pilot in the loop. And so there's a front seat there on the left with a pilot, and that creates an autonomy spectrum or roadmap where you've got a pilot, and then you evolve to a safety pilot, and then at some point you've got a flight director that's just there pushing buttons, and then finally it is truly a curated, fully autonomous flight. The ultimate goal is to get the pilot out of the cockpit, because that is the most important, the most significant cost of any helicopter flight is paying the pilot to fly on board. Between that and jet engines, but we've already pulled the jet engines out on an all-electric aircraft. So with this vehicle, as we're designing it, the wave of technologies that are going into this that I touched on already, it's electric propulsion with incredibly new batteries, powerful electric motors, clean technologies. It does autonomous flying, and I talked about that spectrum. And it's also driving modernized air traffic control. As the FAA and other regulators have known for a while that air traffic control needs to be modernized, but there hasn't been a huge influx in demand in the airspace to necessarily justify it. Well, now there is. There are dozens of air taxi manufacturers and hundreds of drone manufacturers. And so there's an impending storm when it comes to creating air traffic control for UASs, so UAS traffic management, or UTM. This is driving with it demand and talent. So engineering is more important than ever, and specific skills in engineering are more important than ever. Aerospace engineering obviously applies. Electrical engineering is everywhere on here. Software engineering applies not just for people getting software engineering degrees, but largely every other engineer that I hire needs to be able in some way to do computer programming, ideally in Python, to be frank. And then mechanical engineers, obviously, as well. And if they can do Python too, there's a million reasons why we need a mechanical engineer to do Python to help with advanced analysis using finite element analysis for structural load path and studies. So you can't get away from software these days. Everyone's a computer programmer, and they also have an engineering degree in something else. Some skills that we need, I think I beat programming pretty hard. 3D printing is a skill that we obviously need. Electronic hobbyists, we need people that can do hobby grade level electronics, even if they're not an electrical engineer. So I always encourage that. And then 3D modeling and CAD is more important than ever because, aerospace engineers coming out of school may or may not get extensive CAD experience. Sometimes software engineers might need to do a little bit of CAD. It's rare. Computer engineers often need to do some type of circuit design and then figure out how to stuff that into a 3D model. So in large sections, CAD design is difficult to avoid. But I also want to touch on beyond engineering. I want to touch on, we've got industrial designers, which is the creative design of industrial things. Our conceptual designers are brilliant at making good aircraft fly extremely well, but they're not good at making good aircraft look really awesome and Avatar-like, if you remember the movie. We need industrial designers to create that competitive, attractive edge to our vehicles. We also need game designers for simulations, like deep, rich simulations and immersive experiences. And we need product designers, which is basically art on a new palette, understanding the human factors and interaction, the human with the technology. And then we need anthropologists and ethicists as we start looking into autonomy and understanding how are people going to use these vehicles? How will these vehicles transform society? And then also, what does ethical autonomy mean? We also have the autonomous pod transport, which is a radical new logistics drone that flies 100 miles an hour, carries 70 pounds, and weighs 300 pounds itself, 5 feet tall, 9 feet wide. So it is a formidable vehicle. And we're making various sizes of this that weigh more or weigh less and can carry different amounts. There's military and commercial applications here. We're really excited. This product will obviously in my mind, hit the market first because it is unmanned, truly. It's not carrying people, and it's a great way to test the airspace. We've got apt vehicles, prototype vehicles flying today in the airspace in collaboration with NASA and the FAA. To touch on some of the challenges with both apt and Nexus, industrial modernization is going to see more automation. Not at the scale of automotive, but it will see more automation in the manufacturing lines, more complex operations, as you can see in the lower left-hand corner and in the upper right-hand corner. Coexisting with these drones in a very industrial space is going to require new tools and new technologies to ensure safety and control. More complex repairs of these vehicles and a more technical labor force. That's going to be really, really important. And I saw the question there. I'll just repeat my title. I am the Senior Manager of Intelligent Systems at Bell. So another transformation within the industrial base is going to be the factory. It's going to be a lot more machine operators instead of hand layup technicians. It's going to be a lot of repair technicians and robotics assembly and testing and computer coding and testing. And I want to emphasize here that these are people that don't necessarily have bachelor's degrees. And that's a huge gap that I'll talk about in just a second. And then in the field, we've got field operators and repair technicians and automated equipment operations. And these are all very highly technical roles that you don't necessarily need an engineering degree to go do, but you need some kind of post-high school trade school training. I'll touch on some technology trends here. So obviously we've got a lot of digitization and urbanization, electrification and autonomy. I apologize in advance that I couldn't make autonomy AI have the shun at the end because I really like the alliteration. So if anyone has suggestions of the question and answer, please let me know. But this is a complex environment that is really not a bunch of systems being deployed. It is a system of systems, and systems engineers that integrate all of these things is another huge gap. I've got autonomy engineers working on AI. I've got propulsion engineers working on electrification. But what we really struggle with is we need more systems engineers that can bridge autonomy and electrification and digitization of the whole industry and fleet, and then in an urbanized space. And that is a huge gap we have. There are very, very few bachelors in systems engineering, and the old school method of go be a domain expert in a specific area, then go get your systems engineering degree isn't going to cut it today, because I can't wait for people to be domain experts first. I need systems engineers now. So Bell's resorted to having to train our own systems engineer. You got an aerospace engineering degree, or you've got a mechanical engineering degree, but we think you've got the right mindset to zoom out to a 40,000-foot view and be a systems engineer or a system of systems engineer. We'll train you ourselves, but I would prefer not to have to do that. I want to talk a little bit too about at-risk communities, because I talked a lot about job opportunities that are going to exist in the future that maybe don't require an engineering degree, but the communities most likely to pursue trade jobs after high school are going to be communities that also are likely least prepared to be modernized for industrial work. They've got fewer high-tech toys at home. They've got fewer computers in the classrooms. And the barrier to entry on jobs that still require college degrees today becomes barriers to them. If I need an ace computer programmer, but I don't need a software engineer right now, the standard is hire a software engineer. I would like to hire the equivalent of a qualified A&P mechanic that is a computer programmer. And I know certification exists today, and I know there have been announcements from Microsoft and others about how they're going to start seeking people with associate's degrees and or no degrees at all that are brilliant at programming or technical work like robotics and electronics. We need to see more of that, because I think that's going to be an important part of modernizing our trade workforce. It's not always about the degree that you hold, although engineering and engineering design is important too. That's my pitch, other than I'm going to skip my next two slides in case I ran out of time. But in the end, the future isn't something we enter. The future is something we create. And I say that as a bit of a call to action. I don't enter the future. It's my job at Bell, for example, to create the future for digital innovation within the company and externally. And if I've got a passion, for example, for seeking qualified computer programmers that don't have bachelor's degrees, well, maybe I owe part of that to creating an opportunity for at least one individual to come on my team that doesn't have a bachelor degree. And that's something I'm actively working on. And then on the other side, I need people entering the workforce saying, hey, I am very skilled in that space. I can demonstrate that to you. And I didn't need to go get a bachelor's degree to do it. Again, that's different work from truly a software engineer that does different things, but it is a gap, and it will be a gap, even more so in the future. So it's officially the end of my presentation. Feel free to shoot out more questions here. You can always hit me up on LinkedIn or shoot an email to me at mholvey@bellflight.com. Thank you.
Thank you, Matt. So after every presentation, I'd like to just stop and wait for some questions. So now's a great time to ask questions. We'll probably ask questions for about 5 minutes. Matt or Ernest might be able to answer them directly without having to type in. So go for it.
I see a question from Mr. Trevor Benjamin. How best do we address and reduce the danger posed by drones when operating in areas where aerial fighting or firefighting is taking place? I think to answer that question, I know the FAA with the remote ID ruling that's coming out, hopefully December 31st, that's going to give a lot of municipalities the opportunity to put surveillance, what do you call it, drone detection software out there, where we can detect those pilots who are flying in those situations and send law enforcement to deal with them. But to date, without that solution out there, folks don't have that. But in high incidents where they're doing a lot of the aerial firefighting, in particular in Colorado and things of that nature, I know they're really, really looking forward to getting this part the regulations of remote ID out there to alleviate that problem. But that's coming. I think the December 31st will be the start of providing the solution for that.
So does anybody else have any questions? Matt, I think you've got some questions. You can see those, right?
Yeah, I see two up here. I'll address the second one first. Introducing drones into risk communities, how best to do that. Okay. Uh, I don't have the answer. I've got a motto, just FYI. The best way to get feedback is to put the wrong thing on paper, right? It's equivalent to the best way to get an answer on the internet is to post the wrong answer, right? Because you can shout into the wind, hey, we should do something, and everyone will nod their head and say yes, but you won't see any results. So I'm just going to say some things, and they might not be right, but they'll be my opinion. At-risk communities and introducing drones. One thing you do, you just start buying drones and putting them into the classroom. That's one way to do it. I've seen sometimes that that results in a big pile of drones that no one knows how to use because educators need to get educated on how to integrate with these drones. And sometimes the time isn't taken or afforded amidst all the other things that educators have to do is to yet learn this new thing, right? Another problem is sometimes if you invest in drones that are rapidly obsolete, it takes a pretty mature platform to get it into the school systems so that it's fairly, I'm not going to say break proof because I mean I see kids break them all the time in our vertical robotics competitions, but it takes a pretty mature platform where you don't have to know how to do programming and software integration to get these things built like a kit and flying. And by the time you've got a mature platform, it's obsolete. So that's another challenge, is that you buy a fleet of drones and the school system 2 years later is like, why can't I put the latest autonomy on these? And well, it's because it was probably close to being obsolete by the time they were sold to you. And then, however, what I do think is that competitions like Bell's vertical robotics competition, shameless plug there, and there are other great robotics competitions out there, obviously FIRST and others. Those put the burden on modernizing those platforms in the hands of people who are interested in hosting those competitions, like Bell. I'm actually responsible for making sure we have a viable platform, and we're partnering with viable companies each year to provide a tool set that students can easily approach. So that is the easiest thing, I think, is to jump in and say, hey, Bell, hey, other competition company or organization, we don't know anything about drones, but we want to be a part of this. And we'll say, challenge accepted, let's give it a shot. So that's what I would suggest, is building up a little club of robotics enthusiasts and jumping into vertical robotics. Let that kind of ignite a flare or a desire for that work, and then try to fan those flames internally. Also, once other people see that you're engaged in some extracurricular activities like that, they might say, oh, this is cool, we need more of that in my school system, and then you can show up with a laundry list of things that they should be supporting in your school system to do. That's one answer. I'm sure there's a lot of other brilliant ways that we can approach it.
I'd like to get at that real quick because I came from an at-risk community, and I see Mr. Quindell Williams, who currently works providing a drone program at my former high school. And for me, a kid who grew up thinking of aviation, wanting to get involved in aviation in an at-risk community, we didn't have any outlets that would put me in an aviation frame of mind, or even put me on the path to aviation in the community that I was in. Folks like Mr. Williams, what they're doing now, bringing these options into these communities, gives kids like myself that opportunity to take advantage. So continue to do that, put more programs, give these kids and these folks pride in working in this type of industry and learning in this type of industry. And that's what's needed overall, I think. There was one other question though I wanted to get to, because I know we need to get on to the next presentation, but someone asked, it was an automation one. There's a bunch of them now. Wow. Okay. Sorry about that. But I think essentially the question was, if the goal is to go full autonomy, at what point do I tell my students that pilot or small drone pilots will become obsolete? I don't think that's going to ever happen. A lot of the applications that drones are currently being used for, the things that drones are currently being used for, like by law enforcement, fire departments, search and rescue, agricultural, a lot of those folks will still be using, still need pilots. For the most part, pilots will still be needed. The autonomous solution will be those larger companies like the Amazons, maybe your hospital system. Those folks can probably go full autonomy, but for the most part, there'll still be a need for small drone pilots. I wouldn't worry about those folks becoming obsolete anytime soon.
And then I think I'm just going to answer, there's a lot of great questions on here, but I'm just going to answer one about, should high schools try to go a mile wide and an inch deep in industry in knowledge, or should they go a mile deep in industry specific technologies like mapping and agriculture? And my opinion is just, again, my opinion, you need to go a mile deep in one specific use case that really demonstrates something meaningful. Because if you go a mile wide, you don't actually demonstrate anything in particular that's applicable and useful. I think the real hard problems are solved. I mean, when I say hard problems, I mean high school level hard problems are solved when they try to go really, really deep in an area. You will gain a mile wide generalist knowledge while trying to go a mile deep. So that would be my recommendation. And then I'm happy to answer more questions on here, but I don't know how much time you want to spend on this versus moving on to the rest of the content.
Yeah, I'm